Hello all, welcome to Code Hub. Today let us solve the read code daily challenge, and the problem is minimum time to make rope colorful. Alice has n balloons arranged on a rope. You are given a zero interest string colors where colors of I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want two consecutive balloons to be the same color. So she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. So you are given a zero indexed integer array needed time, where needed time is the time that Bob needs to remove the ith balloon from the rope. So return the minimum time Bob needs to make the rope colorful. So here we have given the colors to be A, B, A, C. So you can consider A as one color and B as one color and C as one color. And the needed time is 1, 2, 3, 4, 5. So as you can see that there are two consecutive balloons with the needed time when the balloons can be removed. So what we are going to remove is we have to find the minimum time possible. So we have to remove one balloon which is having a minimum time. So we will be removing the balloon, a third balloon which is having a needed time of 3. So the answer for this is 3. So consider we have a case of A, B, A, C. So for this we are having 1, 2, 3, 4, then 1, then 5. So what we are doing is there are three consecutive balloons with the same color. So we have to remove some balloons such that their time should be minimum. So what will be tend to remove is we are greedily will try to remove. So we will be removing the third balloon and the fifth balloon because they are having the minimum time 1, 3 and 1. So that this three consecutive balloons with having the time will be becoming 1A after removing the third balloon and the fifth balloon. So here as you can see that there are no consecutive balloons. So this is what we are going to do. So as you can see that from this 3, 4, 1 I am removing the smallest if there are three consecutive balloons, I am removing two balloons to make it as to satisfy this condition. They should not have two consecutive balloons. If I tend to have five consecutive balloons, I will tend to remove four balloons, leaving the last one. But I have to make sure that which balloons to remove. So we have to remove the minimum time balloons they have. So as you can see that 3, 4, 1, the minimum times are 1 and so we are removing this 1 and 3 balloons. That is, we are removing the third balloon with the needed time 3 and the fifth balloon with the needed time 1. So that we will have the minimum time as our answer. So finally we will be returning the sum of their times. So for this example, the answer will be 4 as we remove this third and fifth balloon with the time 3 and 1. So which is 3 plus 1, 4. So I will give another example. So B, B, A, C, 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 D. Okay. For this, let us have 1, 2, 3, 4, 5. 1, 2, 3. So D. So as you can see that here we have two consecutive balloons. So two consecutive balloons means we are tend to remove the 2 means n minus 1. So 2 minus 1 which is 1. 2 minus 1 which is 1. So we will be removing this first balloon with the minimum time 1. Then here as you can see that there are three balloons consecutive. So we have to remove 3 minus 1 which is 2 balloons. So the 2 balloons time with the minimum time is 3 and 4. So what we can do is we can remove 7 which is with the time 7. So the here also there are three balloons, three consecutive balloons. So we are removing 3 minus 1 which is 2, 2 minimum times. So 2 minimum times are 1 and 2. So we will be remaining, we will be adding 1 plus 2 which is 3 to our answer. Here there is no consecutive, so consecutiveness. So this is our total answer which is 11. So but how we are removing this? As you can see that if we have the total sum of this three consecutive balloons 5 plus 4 plus 3 which is 12. We if we remove this remove the maximum value because we have to get a minimum time. So if we want to leave the one maximum value balloon. So if we remove the total remove the maximum value from the total sum which is 5. So 12 minus 5, we will get the we will get the minimum time that is needed to remove the other balloons, which is 7. So 12 minus 5, which is 7. So here we are having a total sum of 7. So we have to remove the maximum value from that 7, which is 7 minus 4, which is 3. So we will get the accumulated sum from that from the left out balloons. So that is our required answer. Since we are given needed to get a minimum time, we are removing the maximum time from those total sum. So hope you understand this approach. Let us try to code this approach quickly. So we should have a running sum. So I will have it initially 0, and we should also have a counter variable to see whether this count is greater than 1. We have to remove the balloons which is having a consecutiveness greater than 1. If it is having 2 consecutiveness, 3 consecutiveness, then we have to keep track that also. So we should have a count equal to 0, and I will also have a previous which is initially -1, because whenever this previous is changing, that time I'm going to check for the sum and count on the go. Here for this approach, the time complexity will be order of n, and the space complexity is also, or as a space complexity is order of 1. So it is linear in nature. So this should get accepted. So let us try to go further. So previous is -1. So what are the other variables? We are also want to keep track the max so far. Max so far initially I can have it as 0. And then what are the other things we are in need? We will take the size as well, colors dot size. So what are the things we are in need? So with, I think it is sufficient. So let us try to go for it. We can traverse the array I equal to 0, I less than n, I plus plus. So whenever the my previous is not equal to my colors of I, which means the previous color is not equal, then I have reached some point where there is a break. So what I will be doing is I will check first whether my counter is greater than 1. If this condition is true, then what I should do is I will be adding it to my answer. What I will be adding? I will be adding the total sum minus the max so far. Total sum minus max so far. So I will be adding this to my answer, so that I will get the minimum time. Sum minus max so far. So and then after which I have to reset those values. So I will reset sum equal to 0, previous. I don't want to reset this previous. I will be resetting this counter to be 0, and this max so far to be 0. Max so far to be 0. So I have resetted the values. So I should also have an answer variable. Int answer is equal to 0, or else I will name it as cost. At the end of the day, I'm going to return this cost. So I have resetted the values, but for each and every time what I should do, I should accumulate this sum in my sum plus equal to needed time of I. Then what I have to do, I have to calculate the max so far. Max so far is equal to max so far, comma, needed time of I. Then what I have to do, I have to change the previous is nothing but my colors of I. So I have done these things here, and I have reset the values here. So finally I'm calculating the cost and returning the cost. So hope this should run. So let us try to run the code. Okay, let us see what we have missed somewhere. I think sorry, we didn't increment our count at all, so that is the mistake here. For each and every time I should count those values, right? So that we have missed it. Okay, now we can try to run the code. Okay, I have missed somewhere again. What I have missed? Yeah, actually, this what if we can consider one case? What if this A, this is the consecutiveness and the values are 1, 2, 3, 4. Consider we are having this. So what we will be tending to do is we will be accumulating this total into our sum, and then max so far will be having 4. So the total sum will be 4 plus 3, which is 7 plus 2, 9, 9 plus 1, 10. So we'll be having a sum 10, and then max so far is equal to 4, and then the count will be also 4. But what we'll be doing is we will be coming out of this loop, so we will be not checking this condition at all. So we will copy paste this code outside also, so that this will get calculated. We can remove this, we don't want to reset those values. Actually, we don't want to check this condition at all. We can just directly check if my count is greater than 1, then I will add it to my cost finally. Now let us try to run the code. Yeah, superb, it got accepted, as you can see that. Now let us submit the code. So the time complexity here will be order of n. Superb, it got accepted. Hope you like this solution and let me know in the comments. Let us see in tomorrow's Lead Code Daily Challenge. Until then, bye.